Hello, everyone, and welcome. I'm excited to be here today to introduce our topic, the computer mouse, a primary pointing device. My name is Cesar Carrion, and this presentation was created with Pi. Over the next few slides, we'll explore the history, functionality, and importance of the computer mouse. So, let's dive in and discover how this simple device has transformed the way we interact with computers. Let's take a closer look at the history and evolution of the computer mouse. This section will trace how the mouse has developed from its early beginnings to the modern devices we use today. Understanding this progression helps us appreciate how technological advancements have shaped user interaction with computers. As we move through this part of the presentation, keep in mind that the mouse's evolution reflects broader trends in design, functionality, and user experience. It's fascinating to see how each generation of mice has built upon the last, leading to the highly sophisticated tools we rely on now. So, let's explore the journey of this essential computer accessory and see how it has transformed over the years. So, what is a computer mouse? Well, it's a small device that we use to interact with our computers more easily. It typically sits on our desk and is designed to fit comfortably in our hand. The main purpose of a mouse is to help us control the cursor on the screen, making it simple to select, open, or move things around. When you move the mouse, the cursor on your monitor moves correspondingly, giving you a direct way to communicate with your computer. Most mice also have buttons, usually two main ones, and a scroll wheel, which makes navigating through documents or web pages smooth and efficient. This device is quite essential because it bridges the gap between our hand movements and digital actions. Throughout this presentation, we'll see how the mouse is a vital tool in making our interaction with technology intuitive and accessible. It's a perfect example of how simple devices can significantly enhance our digital experience. Let's take a closer look at what a computer mouse actually is. Essentially, a mouse is a fundamental input device that allows us to interact with our computers more intuitively. It works by controlling a graphical pointer on the screen, making navigation much easier. Its main function is to translate the physical, two-dimensional movement of your hand on a flat surface into a digital movement of the cursor. This was a major step forward in how we used computers, especially when we moved from text-based command line interfaces, where you had to type every command, to the more visual, user-friendly graphical user interfaces, or GUIs, that became standard in the 1980s. The mouse is now an indispensable tool in modern computing. It's the primary way we navigate through GUIs, whether we're clicking icons to launch applications, selecting text for editing, or performing more complex actions like dragging files, manipulating digital objects in design software, or scrolling through long documents and web pages. The design of a mouse typically includes buttons for commands and a scrolling wheel to navigate content quickly. Over time, the technology has evolved significantly, from bulky mechanical balls to sleek optical sensors, aiming for greater precision, better comfort, and increased reliability. These advances have turned the mouse from a simple accessory into a highly refined tool that plays a crucial role in both professional work and casual use. As we see, its continued relevance highlights just how effective and easy to use this device has become in our digital lives. Let's take a look at the history and evolution of the mouse. The concept of the computer mouse dates back to the early 1960s, when it was first developed as a way to make interacting with computers more intuitive. The original mouse was quite different from what we see today. It was large, bulky, and used mechanical parts to track movement. Over the years, as technology advanced, the mouse became smaller, more precise, and more user-friendly. Key milestones include the introduction of optical sensors, which replaced mechanical parts and improved accuracy, and the development of wireless mice, which increased convenience and mobility. These innovations played a crucial role in making computers more accessible and easier to use, aligning with the overall theme of how technology evolves to enhance our daily interactions. Understanding this evolution helps us appreciate how far we've come and sets the stage for exploring the innovative designs and features that continue to shape user experience today. Let's take a closer look at the history and evolution of the mouse. It all began in the 1960s with Douglas Engelbart at the Stanford Research Institute, who invented the very first concept of the mouse. His groundbreaking prototype, which he revealed during the famous Mother of All Demos in 1968, was a simple wooden block with two metal wheels and just a single button. Engelbart's vision was to create devices that could augment human intellect, and the mouse was a key part of that larger system for collaborative computing. In fact, it was a precursor to the modern graphical user interface we use today. Originally, it was called an XY position indicator for a display system, which describes exactly what it did: indicate position on a screen in 2 dimensions. Moving forward, the mechanical mouse became the standard for decades. It used a rubber ball that rolled as you moved the mouse across a surface. This ball turned internal rollers, one for horizontal movement, one for vertical, translating physical motion into digital signals. These signals then guided the cursor on the screen. However, this design had its drawbacks. It was prone to collecting dirt and dust, which could cause the rollers to stick or the cursor to jump, often requiring regular cleaning and a mousepad for smooth operation. In the 1980s, we see the mouse gaining real commercial traction, especially with computers featuring graphical user interfaces. While some early systems like the Xerox Alto or Apple Lisa used mice, it was the Apple Macintosh in 1984 that truly popularized the device. The Macintosh's user-friendly GUI, combined with its one-button mouse, made the mouse an essential part of personal computing. This shift helped move users away from command-line interfaces and into a more intuitive, visual way of interacting with computers. Then, in the 1990s, the optical mouse revolutionized the technology. Instead of relying on a mechanical ball, it used an LED light and a tiny camera to track movement. The camera captures thousands of images per second, and a digital signal processor analyzes these images to detect how the mouse is moving. This innovation eliminated moving parts, which meant higher precision and greater reliability. Plus, it could work on a wider variety of surfaces without needing a mousepad, making it the dominant technology we still see today. So, from those early wooden prototypes to the sophisticated optical devices, the evolution of the mouse reflects a continuous push toward more precise, reliable, and user-friendly interaction with our computers. Let's take a closer look at how a computer mouse actually works. When you move the mouse, the device detects that movement and translates it into signals that your computer can understand. At the core of this process are sensors, most commonly optical or laser sensors, that track the motion relative to the surface beneath the mouse. These sensors send data to the computer about the direction and speed of your movement. In addition to tracking movement, the mouse also detects clicks, which are registered by switches inside the device. When you press a button, it completes a circuit, sending a signal to the computer that a click has occurred. This allows you to select objects, open files, or perform actions within programs. All of these components work together seamlessly to give you precise control over your cursor. This connection between the hardware inside the mouse and the software on your computer is what makes using a mouse intuitive and efficient. Understanding this process highlights how everyday devices like the mouse are built on complex yet fascinating technology, reinforcing the overall theme of how computers translate physical actions into digital commands. Let's take a closer look at how a modern optical computer mouse actually works. The core idea is pretty fascinating. The mouse constantly captures and analyzes the surface beneath it to figure out how it's moving. This happens thousands of times every second, creating a seamless, real-time response that makes the cursor feel instant and smooth. At the bottom of the mouse, you'll find a small LED or sometimes a laser. This light shines directly onto the surface underneath, illuminating it so the sensor can see what's there. A tiny, high-speed camera then takes thousands of pictures of the surface's microscopic irregularities, things like the texture of your desk, a mousepad, or even a glossy surface. The type of light source can vary. LEDs are common for everyday mice, but lasers are used when more precision is needed, especially on tricky surfaces like glass. Lasers can focus more precisely, allowing the mouse to track accurately even where an LED might struggle. All these images are sent to a small but powerful digital signal processor, or DSP, inside the mouse. This processor analyzes the images in real time, comparing each one to the last. By doing this at an incredible speed, it calculates the exact direction and distance of the mouse's movement. It's like performing high-speed vector calculations in a fraction of a millisecond, which is what makes the mouse so responsive. Once the DSP determines the movement, this data is transmitted to the computer, either through a wired USB connection or wirelessly via Bluetooth or RF. The computer's operating system then takes that information and translates it into cursor movement on your screen. The speed of this data transfer, called the polling rate, really impacts how smooth and responsive your experience feels. For example, a polling rate of 1000 Hz means the mouse reports its position to the computer 1,000 times per second. That results in a much more fluid, accurate cursor, especially when you're making quick or precise movements. So, in essence, this entire process, capturing, analyzing, transmitting, is what makes your mouse feel so intuitive and responsive in everyday use. Let's take a closer look at the parts of a mouse and what they do. First, you'll notice the left and right buttons. These are your primary tools for clicking, selecting, and executing commands. The left button is usually used for selecting items, while the right button opens context menus with additional options. Next, we have the scroll wheel, which is right between the buttons. This wheel allows you to quickly scroll through pages or documents without using the on-screen scroll bar. Some mice also have clickable scroll wheels that can serve as additional buttons for shortcuts. Moving on, there are often side buttons on gaming or advanced mice. These can be customized to perform specific actions, like going back or forward in your browser, or executing commands in software. Finally, the bottom of the mouse contains the sensor or ball, which detects your movement. Modern mice mostly use optical or laser sensors that track how you move the mouse across a surface. Understanding these parts and their functions helps us use a mouse more effectively, which is essential since the mouse is such a vital tool for interacting with computers. It connects directly to our overall theme of understanding how we communicate and control digital devices seamlessly. Let's take a closer look at the parts of a mouse and how they function together. First, we have the sensor, which is really the core component of a modern mouse. It's usually an optical sensor, which includes an LED or laser along with a tiny camera that tracks movement on the surface. The sensor's sensitivity is measured in DPI, or dots per inch. A higher DPI means the cursor moves farther on the screen for the same physical movement of the mouse. This is especially important depending on what you're doing. For high-precision tasks like graphic design, a lower DPI allows for finer control. But for fast-paced gaming, a higher DPI helps you traverse the screen quickly with minimal arm movement. Next, we have the microcontroller. Think of it as the control center inside the mouse. It processes signals from the sensor and buttons, turning them into data that the computer understands. It also manages additional features like customizable lighting or onboard memory. That onboard memory is really handy because it stores your personalized button assignments, DPI settings, and lighting profiles. So you can plug the mouse into any computer, and your preferences follow you. No extra software needed. Moving on to the buttons, they serve different commands. The standard mouse has a primary left button for selection and a secondary right button for context menus. The switches underneath can be either mechanical, which use physical contact, or optical, which use infrared light beams. These switches vary in tactile feedback, durability, and response time. High-end mice often include extra programmable buttons on the sides or top, giving you more control and customization for different software functions. Now, let's talk about the connection interface. This is how the mouse communicates with the computer. It can be wired, usually via USB, which offers zero latency and also powers the device. Or it can be wireless, using Bluetooth or a proprietary 2.4 GHz RF dongle. Gamers and professionals often prefer the RF dongles because they offer ultra-low latency and a stable connection that's almost as good as wired. Finally, there's the scroll wheel. Located between the primary and secondary buttons, it allows you to quickly navigate through documents or web pages. Many modern mice let you press the wheel for a middle click or tilt it for horizontal scrolling. Some wheels have a détented design, giving you tactile feedback with distinct steps, while others spin freely for faster scrolling through long pages. All these parts work together to make the mouse a versatile, precise tool, whether you're working, gaming, or just browsing. Now, let's take a closer look at the different generations and types of mice. When we talk about mice in research, we're referring to various strains and breeds that have been developed over time to suit specific experimental needs. These generations and types are crucial because they influence the reliability and relevance of our data. For example, inbred strains are genetically very similar, which helps reduce variability in experiments. Outbred mice, on the other hand, have more genetic diversity, making them useful for studying more complex real-world scenarios. It's also important to understand that newer generations of mice are often bred to carry specific genetic modifications, such as knockouts or transgenes, which allow us to investigate particular genes or pathways. So, when selecting a mouse model, we need to consider the purpose of our study and choose the generation and type that best fit our research goals. Ultimately, understanding these differences helps us design better experiments and interpret our results more accurately. Now, let's take a closer look at the different generations and types of mice. First up is the mechanical mouse. These were the early pioneers in input devices, using a rubber ball to track movement. They served us well for many years, but over time, issues like dirt and dust would accumulate inside the ball mechanism, causing a decrease in tracking accuracy. Because of that, they eventually gave way to more reliable optical technologies. Although mechanical mice are largely obsolete today, they played a crucial role in the evolution of computer input devices. Next, we have the wireless mouse. As the name suggests, these mice don't require a physical cable to connect to your computer. Instead, they typically use Bluetooth or a 2.4 GHz RF dongle. The main advantages here are portability, convenience, and a cleaner desktop setup. Thanks to advances in wireless technology, particularly improvements in battery life and low-latency connections, wireless mice now match or even surpass wired options in performance. This has made them a very popular choice for all kinds of users. Moving on, the most common type today is the optical mouse. This device uses an LED light to track movement with high precision. It has no moving parts, which means less maintenance and no need for cleaning like the older mechanical models. Plus, it works on a wide variety of surfaces, making it very versatile. Because of its balance of performance, reliability, and affordability, the optical mouse is the go-to choice for most everyday computer users. Then, we have the ergonomic mouse. These are specially designed to reduce the strain and discomfort that can come from long hours of use. They come in various shapes, such as vertical designs that mimic a natural handshake position, or trackball models where you move a ball with your fingers instead of moving the entire mouse. Some are modular and customizable to fit your hand perfectly. The goal here is to mitigate risks like repetitive strain injuries, including carpal tunnel syndrome, making long-term use healthier and more comfortable. Finally, there's the laser mouse. This is a type of optical mouse, but it uses a laser instead of an LED. The laser provides a focused, powerful light source, which allows for much higher DPI settings and better tracking on challenging surfaces, like glass, for example. Laser mice are especially popular among professionals in graphic design or anyone who needs the highest level of precision and accuracy. Their ability to track on difficult surfaces makes them a powerful tool for high-precision work. Let's take a closer look at the features and functions of a mouse. A mouse is an essential input device that helps us interact with computers more intuitively. One of its key features is the left and right buttons, which are used for selecting items, clicking, and executing commands. The scroll wheel typically located between these buttons, allows us to navigate through documents or web pages quickly. Many mice also include additional buttons that can be customized for specific functions, enhancing productivity. For example, you might set a button to switch between applications or perform a specific action in a game. Another important aspect is the sensor inside the mouse, which detects movement and translates it into cursor movement on the screen. This can be optical or laser-based, each offering different levels of precision depending on the task. All these features work together to make our interaction with the computer more efficient and comfortable. As we continue exploring the overall theme of computer peripherals, understanding these functions helps us appreciate how a mouse can significantly impact our user experience. Let's take a closer look at some of the key features and functions of a mouse. First up is DPI, or dots per inch. This is essentially a measure of how sensitive your mouse is. A higher DPI means that when you move the mouse physically, the cursor on the screen moves a greater distance. This is especially important for tasks that require precision, like graphic design, where fine control is necessary, or for gaming, where a high DPI allows you to move across the screen quickly with minimal arm movement. Many gaming mice now offer on-the-fly DPI adjustments, so you can switch sensitivity levels instantly depending on what you're doing. Next, let's talk about weight and balance. High-end mice often come with customizable weights, so you can adjust how heavy or light the mouse feels. This is a key ergonomic feature because it helps you find a comfortable feel, reducing fatigue during long sessions. A well-balanced mouse provides stability and control, which is especially important for professional designers or gamers who spend hours using their device. Moving on to polling rate, this refers to how often the mouse reports its position to the computer, measured in hertz. A higher polling rate, like 1000 Hz, means the mouse sends updates more frequently, resulting in smoother, more responsive cursor movements. This is crucial in competitive gaming, where every millisecond counts. For everyday use, a lower polling rate is usually sufficient and can help conserve battery life in wireless mice. Lastly, let's consider the design aspects. Some mice are designed specifically for right-handed users, but many now feature an ambidextrous design. These are symmetrical and comfortable for both left and right-handed users, ensuring everyone can enjoy a comfortable pointing device. And then there are programmable buttons. These are a game changer. You can customize them to perform specific functions or macros, creating shortcuts for software or executing complex commands with a single click. For example, a video editor might assign buttons for save or cut functions, while gamers can program buttons for in-game actions, greatly improving workflow and reaction times. All these features work together to make a mouse not just a pointing device, but a powerful tool tailored to your needs, whether you're working, designing, or gaming. Let's take a look at some of the contemporary trends and advancements shaping this field today. As technology continues to evolve rapidly, we're seeing innovative solutions that are making a real impact. For example, this includes the integration of artificial intelligence and machine learning, which are helping us analyze data more efficiently and make better decisions. Another key trend is the growing emphasis on sustainability and eco-friendly practices, which are becoming central to how organizations operate. These advancements not only improve performance, but also align with global efforts to reduce environmental impact. It's important to note how these trends connect to the overall theme of our presentation, adapting and evolving to meet modern challenges. Staying current with these developments is crucial for maintaining a competitive edge and ensuring long-term success. So, as we move forward, keeping an eye on these innovations will be essential in shaping the future of our industry. Let's take a look at some of the current trends and advancements shaping the world of mice today. First, wireless technology has really come a long way. The performance of wireless mice now rivals, and in many cases surpasses, wired options. They offer low latency, which is crucial for demanding tasks like gaming, and boast long battery life along with reliable connectivity thanks to proprietary RF technologies. This progress has made wireless mice the default choice for most users, primarily because of their convenience and the clutter-free desks they create. Moving on to gaming mice. This is an area where innovation is particularly rapid. High-end gaming mice now feature ultra-high DPI for precision, adjustable polling rates for responsiveness, and lightweight designs often with a honeycomb shell to reduce weight. Plus, they come with dedicated software that allows users to create complex macros and customize lighting effects. All these features are designed to give gamers that competitive edge by enhancing speed, accuracy, and personalization. Another exciting development is the integration of touch surfaces, like on the Apple Magic Mouse. These allow for multi-touch gestures, swiping, scrolling, pinching, making the user experience more fluid and intuitive. While this sleek, minimalist design is appealing, it does come with some trade-offs. It may lack the tactile feedback and precise control that many professionals and gamers prefer with traditional buttons. Then, there's the field of ergonomic design, which continues to evolve to promote healthier and more comfortable use. Recent innovations include modular mice, where you can swap out components to better fit your hand. Trackball mice with advanced sensors provide precise control without moving the entire device. Vertical mice are also gaining popularity because they promote a more natural wrist position, helping to reduce issues like carpal tunnel syndrome. The goal here is to make the mouse feel like a natural extension of your hand, which ultimately improves comfort and reduces strain. Lastly, multi-device connectivity has become a game changer. Many modern mice can connect to multiple devices, like your desktop, laptop, or tablet, and switch between them seamlessly with just a press of a button. This simplifies workflows, reduces desk clutter, and even allows you to move the cursor across different screens as if they were part of a single, continuous desktop. All these advancements highlight how the mouse continues to evolve, integrating new technologies to improve performance, comfort, and usability in our increasingly digital world. Thank you so much for your time and attention today. I really appreciate your engagement and interest in the topics we've covered. Remember, the key points we've discussed, from the importance of innovation to the strategies for effective implementation, are all aimed at helping us move forward successfully. I hope this presentation has provided valuable insights that you can apply in your own work. If you have any questions or want to discuss further, please feel free to reach out. Once again, thank you for being here and for your commitment to growth and progress.